Most any given class instance can take on both active or passive qualities. This is known as its state. A passive state is simply the current status of an object's attributes. For example, consider a GPS device in a car, which is stationary. The coordinates, the elevation, even the direction are not changing because it's stationary, and thus it is in a passive state. In comparison, when you start moving with your car, your GPS device is now in an active state. That's because the status of the object is undergoing a continuous transformation. An event, or sometimes more accurately called a trigger, occurs when something happens to cause the object to move from an active state to a passive state, or vice versa. So in our example, the trigger could be engaging the engine, which would start the process of us moving. Likewise, applying the brakes to our car would cause us to stop, and once again the state would change, this time from active to passive. This happens in many different programs and events, and physical motion doesn't have to be a trigger. A trigger could be submitting a form so you change your college major, or maybe you apply for a job. It could be tied to pressing a button which kicks off a different series of events, etc. Now, a state diagram is used to show how an object can move between different states. And this is more than just active or passive. That is a descriptionary. These types of states will allow you to say what the element can do. Now, in some cases, you can stay in your current state when something happens and continue the work that you were doing. For example, you might have a user on a web page. They go to enter their credentials, but fail at doing so. The state will update, identifying that there was a failed attempt, but it will allow them to try again. They may do so several times until the state will change from maybe a login enabled state to a login locked state, which at that point they're no longer allowed to try to attempt to log in for a certain period of time. Why? Well, your systems try to prevent hacking. You may have just a couple of states to very many states, and what state allows you to go what other state is going to be one of your design decisions. So in our login example, you might have a login attempt state, which can then lead to either a login success or a login failure, or once again, staying in that login attempt state. If it's part of an e-commerce site, maybe that's the only states that you can go to from that current state. However, you'll have many other states throughout that website. So, for example, you might have a customized product state. You might have an order the product state or add to the shopping cart. You might have a return to search or any number of other states that you're going to have based upon the needs of that website. Remember, when you're building an application, you need to give your users an appropriate number of options without making it too complex to understand what's going on. Many times, each of these options could be referred to and viewed as a state. Because of this, you can diagram your different states to help you keep track of where a user is and to help you know where they can go from there. You can then connect each state to the other states that they're able to connect to simply by using a line. Between the states on that line, you'll add some text that's going to describe what's occurring to make you move from one state to the next. While a state diagram is good for when you can move back and forth between different states, you sometimes will need just a simple sequence diagram. And this is used when you always want to show that you're moving in a set number of predefined procedures. Therefore, a sequence diagram shows the steps or sequence in which a process occurs. It lists each item on a separate column and with each step given in its own separate row. Arrows can easily show from where you move from one step to the next.